Now we are going to attempt question number 16 to 21, and while attempting questions 16 to 21 we are going to learn two new methods, the weighted average method and the alligations method. Both of these methods are excellent, but they should be used for different kinds of questions. Both of them do give us answers, but they should be preferred in certain kind of questions. So let's learn that. Look at this question number 16, read it once again. I'll give you a moment. After that I'm going to read it for you. The reason why we're spending so much time on reading the question is that reading and understanding the question properly is the first step in solving the questions correctly. So take your time. Read it. I will read again for you. It says we have two mixtures of milk and water where the first mixture contains 40% milk and rest 60% is water, and the other mixture contains 75% milk and the rest 25% is water. These two mixtures are mixed to create a third mixture and is known to contain 60% milk and the rest 40% is water. Find the ratio of volumes of the first to the second mixtures used to make the third mixture. To visualize and correctly understand what the question is saying, uh, we have two mixtures of milk and water, and the first mixture has 40% milk, the second one has 75% milk. First one has rest of it is water, so it's 60% water, while the second mixture has 75% water. Both of these mixtures are mixed together in order to get a third mixture which ends up having 60% milk and 40% water. Now, in this question, the challenge is to find the ratio of volumes of the first mixture to the second mixture in order to get the third mixture. We'll first check the first method, which is the weighted average method. In the weighted average method, we'll start with assuming the volumes of the two mixtures being X and Y. Then the volume of milk in the first mixture has to be 40% of X or 0.4X. On the other hand, volume of milk in the second mixture should be 75% of Y or 0.75Y. So the total volume of milk in the third mixture should be equal to 0.4x plus 0.75y upon total volume, which is x plus y, multiplied by 100, and this turns out to be 60% of milk. So we end up setting up this equation and we simplify it. On simplifying it, we end up getting x upon y equal to 3 by 4, and that is our answer. So by the weighted average method, you do end up getting perfectly right answer, but there's a certain amount of calculation involved. So let's learn another new trick. The second method by which we can solve the same question is called as the alligations method. In the alligations method, we develop the following diagram. We make a simple square, and whatever is the value of milk in case of the first mixture is written here. Whatever is the value of milk in the second mixture is written here in the top right corner. Once we have done this, the final volume of milk in the third mixture is written in the middle. After this, whatever is the diagonal difference between these two values, 60 and 40, which is 20, it is written in the bottom right corner. Whatever is the difference in values of 75 and 60, that is written here. 15, 20 is the values which you end up getting here after calculation. And this is the ratio that we are looking for. So desired ratio of x and y has to be 15 by 20, which on simplification gives you 3 by 4. This is the alligation method. In the alligation method, you do not have to do lengthy calculations. You do not have to set up an equation. This is very simple. You possibly do not even have to make the square. Just write down 40, 75, 60, end up getting your final ratio. So you have to take a decision that if you get this kind of a question, will you go in for a lot of calculation by the weighted average method and get the right answer, or will you go in for the alligations method which does not require calculation, which does not require you to set up an equation where chances of making a silly mistake get increased, you still end up getting the right answer here. So in case of this kind of a question, you should be using the alligation method. Let's do one question. Uh, Read this question carefully. The question says two varieties of rice costing rupees 12 per kg and rupees 19 per kg are mixed to create a new variety costing rupees 15 per kg. What is the ratio in which the two varieties are mixed? While doing this question, we set up our box and we write 12 and 19 on top. The final variety is the one which costs 15 rupees per kg. We write that here. And now we look for diagonal differences and we end up getting our ratios. Difference between 15 and 12 is 3. That's how you get a 3 here. Difference between 19 and 15 is 4. That's how you get a 4 here. So the desired ratio in which the two varieties are mixed is 4 by 3. So in case of these kind of questions, remember the rule of alligation is found to be more useful when you have to calculate the ratio of weights, ratio of volumes, or ratio of amounts. That's another term which is used in some questions. For example, if you have a milk water mixture and you've got to find the ratio in which the two mixtures were used, then the rule of alligation is very useful. It should be used here. But take care, if you are given the ratio of volumes and are asked to find the resultant milk or water concentration, then it is best to use a weighted average formula instead of the rule of alligations. So rule of alligations is to be used when you have to calculate ratio of weights, volumes, or amounts. On the other hand, if you have to find concentration of the final mixture, then in that situation, the weighted average formula ends up giving you perfectly right answers easily. So this formula is not a bad formula, weighted average formula. For example, if you look at this question, it says, if the two mixtures of milk and water having milk concentrations as 40%, 75% are mixed in the ratio 3 by 4, what is the percentage of milk in the resultant mixture? Now, in this question, milk in the resultant mixture is equal to 40% of 3 plus 75% of 4. You multiply and add them, divided by the total volume, which is 3 plus 4. So 120 plus 300 by 7, you end up getting 420 by 7, which is equal to 60%. So you get the answer easily, because it is asking for milk percentage. So wherever the question in the end is asking for the percentage of a particular ingredient, then the weighted average method works perfectly well there. Now let us see what happens when we do the same questions by the alligation method. The question remains the same. We draw up our box, write 40 and 75, and the final ratio is 3 by 4. So we write that here. But I cannot get a number which shows the difference between 75 and 3 being equal to 40 and 4. So we'll possibly have to go in for multiplying this ratio 3 upon 4 by some number upon the same number in order to get a respectable value, the right value. When we multiply 3 upon 4 by 5 upon 5, then we end up getting the ratio of 15 and 20. And based upon that, we can end up getting the value of 60 here. So this makes the whole procedure clumsy. So whenever final concentration of an ingredient in the resultant mixture is asked, please do not use this alligation method. It doesn't work there. The weighted average method works here. So let's look at question number 19. It says a grocer mixes 28 kg of tea costing 6.2 rupees per kg with 12 kg tea costing rupees 8.4 per kg. Find the cost of the resultant mixture per kg. Here they ask for the cost of the resultant mixture per kg. So when I go in for solving it, if I try the same method here, make a box, write down 6.2 here, 8.4 here, and then I write 12 kg here and 28 kg here, I'll have a problem. I'll have to figure out a particular value which is the same in terms of difference between 8.4 and 28 and 6.2 and 12, and I'll have to do a lot of permutation combination in order to get that answer. So it is better to go in for the weighted average method. The cost of the mixture per kg is equal to 28 multiplied by 6.2 plus 12 kg multiplied by 8.4 divided by the total weight, which is 12 plus 28. We simplify it further, calculate, and we end up getting our answer, which is 6.86 rupees. So weighted average method works better in case of this kind of a question. Let's look at, take a moment with this question and then we move on to the next one. In case of 20th question, the question is simple. It says, in what proportion should a grocer mix tea at rupees 1.02 per kg and rupees 1.44 per kg so as to make a mixture worth rupees 1.26 per kg? While solving this question, we go in for making a box, write 1.02 and 1.44, and the final mixture is worth 1.26. That final mixture value would come here. Now we look for the differences. The diagonal difference between 1.26 and 1.02 is 0.24, and the diagonal difference between 1.44 and 1.26 is 0.18, which gives us the ratio, which is 0.18 by 0.24. We simplify it and we end up getting the ratio 3 by 4. That's our answer. So wherever alligation method can be used, please use that preferably. And there are some situations where you have to clearly go in for using the weighted average method. This is the last question of the slot. Take a moment to read it carefully. The question says a merchant has 50 kg of sugar, part of which he sells at 8% gain and the rest at 18% gain. He gains 14% on the whole. Find the quantity sold at 18% profit. While solving this question, we can set up the box. We write 8 and 18 on top and 14, which is the final gain, in the middle. We look for the difference between 8 and 14, which is 6, and then the difference between 18 and 14, which is 4. And we now end up getting a ratio. So the ratio is actually 4 by 6, or after simplification it becomes 2 by 3. But we have to find the quantity which is to be sold at, which was sold at 18% profit. So we'll have to do one more calculation. So the quantity sold at 18% gain would be equal to 3 upon 2 plus 3 multiplied by 50, which is equal to 3 by 5 on simplification into 50, which is equal to 30 kgs. So this alligation method, wherever you can use it, please use it. But wherever the final percentage of an ingredient is asked, there you should avoid it. You should go in for using the weighted average method. Look at the question, see how we solved it.